Today we are going to do section 7.1 on page 683, systems of equations. Now first let's look at this page and look at three graphs. Okay, now if we have some kind of equation such as let's see, well, on this page there is no equation to look at. All right, maybe I'll look at the previous page. Okay, here's an example of a system of equations. This is on the page before, or you can make something up in your head. Either way, so let's say you have equations 2x plus y equal to 15 and 3x minus y equal to 5. That is, you need to think of two numbers such that 2 times one number plus the next number is 15, whereas 3 times one number minus the next number equals to 5. Okay, there are a lot of funny or trick questions in the lower grades that's similar to this. So then, so how will we solve this? Now, these two equations, you can graph them. They're both straight lines. And anything that you have a number times x, and then plus a number or minus a number times y, and that equal to some number, positive or negative, that is a straight line of some sort, okay? It points whatever direction. And so if you graph them, then you have two straight lines, and here are the three possibilities of your two straight lines that you graphed out of the two random equations. The first possibility is that the two lines intersect, right? And then they intersect at a point, and when that happens, then the point of intersection is on both lines, which means that point, the common point, satisfies both equations, which means that point is the solution to the two equations. So basically, if you want to find the solution of two equations, you can always just graph it. That is, type it into the graphics calculator and see where it intersects, and that is your solution. So the second possibility is that what if the two lines don't ever intersect, okay? I mean, what if they are parallel? If they're parallel, that means they have the same slope. And if they have the same slope, then they will never intersect. And in that case, there is no solution, okay? In other words, there is not a single point in the universe that's on both the first line, the blue line, and on the red line. Okay, so that is the second possibility. There is yet a third possibility, is that the two lines are actually the same line. You just give it a different name. That is, they are, or put it this way, they are right on top of each other. Okay, so you cannot, well, they're the same thing. And then, so in that case, there is the solution is any point on the line, because your solution is a point that is on both lines. Well, both lines are on top of each other, so every point is on both lines, right? So then the solution is everything, which tells you nothing. Okay, so that is so mostly we're interested in the first situation where you have two lines that's intersecting, and we want to know what is the point that's on both lines. So that is what we're going to be doing in this section. Next, I want to remind you a formula that we learned in chapter 2. Yeah, I think chapter 2. That's the point slope formula. That is, if you're given 2 points, that's the first point, that's the second point, then there is one straight line that goes right through the 2 points. And the equation is given as y minus y1 over x2 x minus x1 equal to, sorry, I made a mistake there. So again, the equation is y minus y1 over x minus x1 equals to y2 minus y1 over x2 minus x1. Now the x1, y1 and x2, y2 are all numbers, whereas the y and x are the variables. That thing is called the point slope formula or something like that. Specifically, this thing right here, the difference in y and the difference in x is divided, okay, it's called m, which is the slope. And that we probably won't be using that in this section, but I want you to remind you of that formula, because we're doing something similar here. We're doing straight lines intersecting and stuff. So I want you to remind you of this formula, because this is extremely important formula to be, probably the most important formula to learn in algebra. Okay, so once in a while, it doesn't. I would like to just remind you of this thing. And so, having said that, let's move on. Okay, so what are we doing here? Let's look at example 1 on this page, which is at the bottom of the page. And we need to determine whether an ordered pair is a solution to a system of equations. Fine. An ordered pair means a point, okay? A point has 2 coordinates, and this point is called 5, 1. And let's look at the next page. So the next page, we have a system of solution, which is x plus 3y equal to 8, and 2x minus 9 equal to y. Now remember, x equal to 5 and y equals to 1. So by just looking at that, okay, let's see, do we have that? Yeah, right here. Okay, so now all the information is on my tablet. So then if x is 5, y is 1, does this satisfy those equations? Let's do that right now, okay? X is 5, y is 1, 5 plus 3 is 8, 2 times 5 is 10, minus 9 is 1, which is 1 here. So the answer to example 1 is yes. That's it. Okay, so then, and if you plot the graph out of there, if you plot the graph of this thing, okay, into the Desmos calculator and graph or some other graphing calculator, you'll get something like this, where they intersect at 5, 1. As we have already confirmed by by plugging the number into both equations. Now the second, let's next look at example 2, where we have 2 simple equations, and we're supposed to graph them. Okay, so let's look at that. Now to graph these equations in the Desmos graphing calculator, then you type it in as is, like this. Okay, and what the book wants, that is, you type in 2x plus y, etc. in the first line, and then type in this thing in the second line, and the graphing calculator will give you the answer right away. Excuse me. Now the thing is, however, you notice that the book wants you to isolate y first. Okay, it says, why don't you manipulate something so that y is on one side and x is on the other side, and do the same thing to the other equation. Okay, I mean, here are 2 equations. They want you to plug y out of each equation. The reason is because the handheld calculators, like this thing I have here, okay, these calculators require you to do that because they're not as smart as the Desmos calculator, which does not need you to plug y out at all. I mean, you can just type the thing in and as you see it, and you'll know what to do. Okay, so so use the Desmos calculator, which is free if you can. All right, the handheld things cost like over $100 that I paid for, and so I hope you don't have to use it. Okay, and if you don't have to use it, don't use it. Ugh. If you have Desmos calculator available. If you have no access to the Desmos calculator for some reason, then of course the handheld calculator is better than nothing. Anyway, it's not better than nothing by a lot though. I mean, I don't like that. I never liked the handheld calculator, even back in the day when Desmos calculator wasn't available. Anyway, it was just too ugly and too tedious and too hard to type it in out of the tiny keyboard on the calculator. You need to type, I mean, with a regular keyboard to type in formulas or anything is so much easier. Anyway, let's see. So that is example 2. Okay, so far so good. So the next step, let's now look at example 3 on page 686. So we're going to solve this thing by substitution. Now, to do substitution means you plug one variable out and plug it into the other one. Okay, and you can, which one should I take out? Well, whichever one looks easier to you. And so in this case, we will we'll do what the book says. I will name these equations 1 and 2 for easier reference. Okay, the book doesn't do that. You don't have to. Anyway, so from equation 1, then I get, we'll take y out, which is also what the book does. So we take y out, that becomes minus 5 plus x, right? So that is y. Now remembering that, we'll put it inside 2. Let's put it into 2. That is the y value in here. Okay, so then we have 2x minus 5 times, y is this thing, right? I write it down here, 5 plus x, and minus 5y, and then equal to 1. So that I put actually, no. that wouldn't be quite true. Well, sort of true. Forget it. Anyway, the point is I put this in the y position. Okay, so this is y right here. And then now I have an equation with just x in it. And then, so to solve, after I solve this equation, everything will come out. And so if you have, if you are rusty about solving equations, please review chapter 2, certain sections of chapter 2 that I have in the video description on how to solve equations properly. You need to know solving equations very, very well, because right now we're doing solving 2 equations at the same time, which means you do twice as much work. In fact, after solving 2 equations, system equations can go to 3 or 4 or 5 equations all solved together. So you seriously need to know how to solve just one, okay? And anyway, so please review chapter 2 if you have any trouble with this kind of thing. And so we are going to do this. Now, this is 2x, right? Minus 5x, that's negative 3x. 2 minus 5. And then we have 5 times 5, that's positive 25. Put it over here, becomes negative 25. And plus 1 becomes minus 24. Okay, so then x should be equal to 8. Now, if x is equal to 8, we'll plug it in here. That gives us a minus 8, okay, plus y is going to be equal to 5, which means y equal to 5 plus 8, right? Move the 8 over here. 5 plus 8 is 13. And that should be our answer. That is 8. Nope, I messed up. How did I mess up? It says minus 5. Why? Oh. That's because I wrote it down wrong. See, minus 5. And minus x plus y is minus 5. Ugh. Now, don't make my mistake, okay? Do not miss the negative sign. Minus 5, that changes things. So if it's minus 5, then y is not 13. That is, becomes positive, right? It becomes 8 minus 5, which is positive 3. All right, so that should be the answer to this problem. Okay, so next, let's look, that is the substitution method. Substitution method means you yank one of these things out and stuff it into the other and hope that everything comes out and you don't make any mistakes like I did. Okay, do not make mistakes if you can help it. If you do make mistakes, then you have to fix it. It's not the end of the world, but it's better that if you don't. And so next, let's look at the next problem, example 4. All right, so I will write it down. Okay, now this one we have, anyway, so we have these 2 things, right? And then we'll do the so-called addition method. That is, we'll add it together in such a way that you'll get rid of one of the variables. Now, you notice that there is the x here, and there's a negative x here, which means we can we can add them together, and this will disappear, and we'll have just y. Okay, and it's okay to add 2 equations together because the things are the same on both sides. So if you add it up, the equation holds. Okay, you're not doing anything odd. So let's put the equation here and let's add these things together. Then we get x cancels out. Then we have 3y total, right? And this becomes 2, and that gives us y equal to 2/3. And once we get that, we can put the y value in one of these things. Let's put it in 2, okay? And we'll put it in 2. If we put it in 2, then minus x plus y equal to 2/3 is going to be equal to 3, which means x equal to 3 minus 2/3. That's 2 1/3, right? And that should be the answer. And that can also be 7/3 if yes, so y is 2/3 and x is, but the book says x is negative 7/3. Oh no, I forgot x has a negative sign here. So minus x is 2 1/3. Or, so which x means x is negative 2/3, 2 1/3. And I forgot the negative sign again. Please don't make my mistake and somehow forget the negative sign for no reason. Now you can check the solution by putting x and y back in both equations to see if they really are right. If I do that, then I would likely notice how I messed up, right? And forgot the negative sign. So if we plug this stuff in there, which is very tedious to do, okay? But it can be done. And let's do it with a calculator, shall we? Yeah, that would be so that is a good calculator practice, especially because it has fractions. So let's see. So we have, let me stand over here, yeah, that way you can see the screen and the stuff. All right, let's see. So what did I have? Y is 2/3 and X is and I plugged it into equation 2. Right? So we'll test it in equation 1. So X is negative 2 1/3. That is, let me turn on the calculator. That is negative, let's see. This is not working out. Let me think. All right, so we are going to, let's see, X is negative, we got this equation from 2, so we're going to plug it into 1, okay? And so we have X equal to minus 2 1/3 or minus 7/3, 7 divided by 3, okay? Plus 2y, which is 4/3, plus 4/3. And that should be equal to -1. It is. All right, so then we're good. And being that we found the equation from 2, plugging it into 1 works, that should be good enough, okay? And you can also plug in both. That would be even more sure. But plugging in the first one is probably sufficient. So that is that's the end of example 4. And next, let's move on to, let's see, example 5. All right. Let me write this problem down. Now for this problem, we are supposed to do addition method again, but unlike this problem, which is very conveniently has an x on in the first one and minus x on the second one, so we just add it very comfortably. This one is not so simple. They don't have, you know, the 3x, and we need the negative 3x here, but it doesn't have it. So what we're going to do is turn it into that, okay? So what we're going to do is change this, the second equation, into a minus 3x. So it looks like that, and then we can add it up and make the 3x disappear. So to do that, we will multiply by negative 3, so to make it into 3x. Minus 3. Now if we multiply by minus 3, then everything else has to be multiplied by minus 3 as well, to be fair. So that becomes minus 3 times minus 2, that's positive 6y, and equal to minus 33. All right, now we can add these two things, okay? So this we'll call equation 1, and I'll call this equation 3, and we will add 1 plus 3. I just write this stuff down because that's how I was taught to do it, and but you don't have to, okay? You can just, well, go ahead and add this stuff. So let's add this. This becomes 0 as we intended. 5 plus 6 is 11y. So we have 11y, which equal to minus 11 plus minus 33 is minus 44. Minus 44, which give us y equal to negative 4. And then if y is negative 4, then we need to figure out what x is. The easiest way is probably use this equation right here. If y is minus 4, then x is going to be equal to, isolate x here. So put the 2y on the other side. That becomes positive 2y plus 11, okay, where 2y equals to minus 4. That becomes minus 8 plus 11, so that should be 3. Positive 3. So y is minus 4, whereas x is positive 3, and that should be our answer. Yep, and it is. If we were to check the solution, we did this with equation 1 plus equation 3. So if we want to check it, we'll put it back into equation 2. That is, because we already used equation 1 and 3, so if we put it in equation 2 and it works out, that should be good enough, I hope. And anyway, so x is 3, okay, and y is negative 4. 3 minus 2 times 4 is 8, okay, that's plus 3 plus 8, that's 11. So that is working out good. So that is that's the end of example 5. So next, let's do example 6 on page 689, where we have two equations. Now, if we just multiply by one equation of these variable, it doesn't necessarily become the other one. Okay, and so what happens is sometimes we might have to multiply both equations by some kind of number, and then so then two of them end up the same. Now in this case, the most obvious thing to do right now is just to multiply this equation by, say, 5, right? That end you with 10x, and multiply this equation by 2, and which will also end you with 10x. Now however, I'm not going to do that because this equation happens to have a hidden point here. See, the second equation, unless I wrote it wrong, maybe I wrote it wrong. Why would they say that? 5x minus 10y equal to 30. These have factors of 5 in there. Okay, so what we're going to do is turn this thing into 2x. We'll multiply this entire equation by 2 over 5. So let's multiply this whole thing by 2 over 5. Okay, but this whole thing. So 2 over 5 times 5, that is, let's put a negative sign here too. All right, so this times that is going to be negative 2x, okay, and then this is what, plus, okay, cancel out the 5, have a 2 left, so 4. Right, negative and negative becomes positive, so 4y equal to minus 12. Okay, and then if that is the case, we have a minus 2x here, and then there's a plus 2x here, so I don't have to do anything there. Okay, that's just because this problem is it already has a common factor, which the book shouldn't have done. They must have missed it, and because then I don't have to multiply both equations by something. But other times you might have to, okay, just to make it so that this is the same as that. But I can do it by simply multiplying it by this number, and then it becomes 2 and negative 2 here and positive 2 there very nicely. So now we can add this plus that. Okay, so let's add equation 1 and equation 3. So let's add them up, 1 plus 3. Then that gives us, and so that's 0, right? Plus 3 plus 4, that's plus 7. And we get 7y equal to, and then negative 16, negative 12, that's 28, minus 28. So that gives us y equal to minus 4. And then and from there we can find out x from this equation. Then we get 2x plus 3y, okay, 3 times minus 4, and that is supposed to be equal to negative 16. And if that is the case, that's minus 12, and add up over here, that is equal to minus 28 again, right? And that, which equal to 2x, so that gives us x equal to half that much. X should be minus 14. Okay, so that is so x is minus 14. Examples, y is minus 4, that's correct. X is minus 2. Why is that? I must have messed up something. Let me check. Yeah, I found my mistake. Minus 4. Okay, when we put it over here, it's plus 4. So it is not negative. It's not negative 28. It's minus 16 plus 12, not minus 12. So minus 16 minus plus 12, excuse me, that end up with minus 4. And so then x is then equal to, didn't I say 4? Now, yeah, see, minus 14 plus 12 is minus 4. All right, 4. So then x is equal to minus 2. X equal to minus 2, and that should be much better. Okay, is that right? Yeah, now we got it correct. See, I mess up this kind of problem all the time because I'm always missing out the negative signs. The negative signs are like the death of me, okay? At some point, I was teaching advanced calculus, and there was one point where we have to do minus 1 times minus 1 minus 1 plus minus 1. And I did that problem like 5 times. They call the cross product, and I couldn't get it right. And finally, I had to use the calculator. It was very sad. Yeah, some part of my life is, you know, sadder than others. Anyways, let's move on. That is example 7. Okay, let me write that down. Next, let's look at example 7 on page 690. So we have this particular example there, right? And your book wants you to do is multiply these things. The only trouble with this problem is that it has fractions. So what do we do? Well, one way is to get rid of the fractions by multiplying by the least common something. And in this case, it's 6. If you multiply by 6 on both sides of the equations, then you get this nice little equation similar to the next one. You also get a nice little equation. Now that only happens because these fractions are very beautiful, right? 3, 6, 2, 4. It's so easy to come up with the least common multiple. If the fractions were uglier, then you have much more of a struggle coming up with something, and then it's not as neat. Now so I'm going to do this in such a way that the fraction is uglier and more irritating to look at. And I'll just give you a straightforward way and forget the least common multiple. We'll just, you know, pound this thing through. In other words, let's do this. These are fractions, right? So then we'll isolate x, okay? Everything is under fractions, so the one's as good as another. So let's plug x out of something from, let's say, equation, this we'll call equation 1, okay? And this I will call equation 2. Now from equation 1, let's plug x out. Okay, what's x from equation 1? X will be equal to, first we have move y to the other side, so 3 minus y over 6, right? And then, so x is divided by 3, so we'll multiply by 3. Okay, push the 3 across equal sign to the top. Okay, things get, when you cross the equal sign, you either push down or push up. Okay, that's called cross multiplying. Now so this is x, okay, and we're going to plug this thing in here. So this will be plugged into, I'll draw an arrow that means into equation 2. If we plug 1 into equation 2, then we have this whole thing here, okay, which will be, let's see, all right, let me write that down. 3 minus y over 6 times 3 divided by 2. Okay, this whole thing is x, right? And so x divided by 2, and then minus y over 4 is going to be equal to 1. And now we're going to solve this equation, and if we do, we will get the answer for y immediately, because y is the only variable here. Okay, and so we will solve the equation with the skills that we learned in chapter 2, and that's times 3, and then we have well. All right, so how do we do that? Let's simplify this slightly. That gets us, that's 3 over 2, right? Minus, that becomes y over, that's 3y, the 3 and the 6 cancels out to become 2, and then 2 times 2 is 4. So this is equal to y over 4. Now this is a manipulation of fractions that a lot of students have trouble with, and so please pay attention on how to do this exactly. Okay, if you have trouble, then I think chapter 1 has rational expressions or something. Anyway, it teaches you how to do fractions. So this is again, so this is 3y over 6, then divided by 2. So then it's the total of dividing by 4. Why do I have 2 there? So divide by 2 and then 2 again. So you're dividing by 4 total. So that should be right. 4. And then minus y over 4 equal to 1. So then now we're going to sum up all the y's on one side. Let's put the y on that side. So y equals to y over, so minus y over 4 minus y over 4, that becomes y over 2. And on that side, it becomes positive. And then put the 1 over here, that becomes minus, okay, minus 1 plus 3/2. That is a total of, what is that? Isn't that 1/2? Yeah, I think so. Yeah, that is positive 1/2. So that gives us, that means y equals to 1, okay? And that is a very clean answer. If y is 1, so x equal to, we'll plug 1 into equation 1. Y is 1, that 3 minus, well, whatever. I might have messed up on the fraction here. I hope not. So let's try this. If y is 1, we have 3 minus 1/6 times 3. And that equals to, I'm not even going to do that. I will just use my calculator. But first, let me check to see if y it really is 1. Because if I'm wrong, no, the book says y is 7. So let me see where I made a mistake. All right, I see my mistake right here. Okay, this is not 3. 3 times 3 is 9. That thing is supposed to be 9. So let's fix that. That is equal to 9. Okay, 3 times 3 is 9. So 9 minus all this stuff. So 9, that is what equal to y over 2. Okay, now let me see what is. So we have 9 over 2 minus this. So we have minus 1, and then this instead of 3 is 9. That's what it is. Okay, then that does not equal to 1/2. That equals to 7 halves. 7 halves. Okay, which is why y equal to 7. See, y over 2 equal to 7 over 2, so y equal to 7. Okay, let me double check here. Yep, y equals 7, so we're good. Now then, if y is 7, so this becomes 7. And now let's crank this thing out, see what it says. Let me double check. Let's see, we are doing, yeah. Whatever. Let's calculate it and see if I got it right. Okay, so x equal to 3 minus whatever. Let's okay, so we'll do 3 minus 7 over 6, 7 over 6, and 7 over 6. Okay, and times 3. That means 11 over 2. All right, let's see. Is that right? Yep, it is. X is indeed 11 over 2, so we're good. Okay, so yeah, I forgot that 3 is multiplied by 3. I probably shouldn't have written down this cancel business, because then I forgot that the 3 is not being canceled over here. You see, it's only canceling here. So I should probably write the 3 without being canceled. But it is canceling with the 6 here, and that's how we got the first y equal to 2. Anyway, so that is example 7. Now the benefit of my method is just so that, I mean, for this problem, there's no benefit, okay? I mean, this is such a easy, comfortable problem, 3 and 6, 2 and 4. But if it was 31 and 61, and then say 23 and say 47 or something, so you have all kinds of weird numbers, then this method will likely go faster. I just want to show it to you, okay, so that you know there's more than one way to skin the cat. Which way you use is really depends on the problem. Most of the time, if the problem is nice, which is more likely in algebra, although nowadays it seems like sometimes they'll make you suffer through a annoying problem. But either way, that it is true that the way the book does is faster and less likely to be messed up. Anyway, but I just want to show you that. And with that, so please do the books method yourself, okay, for example 6, which is very comfortable, okay? You just multiply by 6 and you end up with this beautiful thing. See, there's a plus y and there's a minus y. You just add it together and you can practically do it in your head, what x and y is, just from this stuff. All right, so that is that, example 7. And next, let me clean the board. Next, let's look at example 8 on page 691. But before that, I want to mention this equation. Now, this equation is the same as this one, just written differently. That is, this thing is m, right? So you can write it as y equal to m times x minus x1, and then plus y1, that is, put the y1 on the other side. So this is the same equation as this. As you notice that m is the slope. In other words, anytime you see an equation of this kind, if the number before y and the number before x is what determines the slope, m. Okay, and that we must bear in mind when we consider this equation. So this equation, we have x equal to 9 minus 2y. That's the first equation, and then this equal to 13, etc. Now let's look at the equation 1 more closely. If we rewrite equation 1 down here, I'm going to rewrite it. Okay, that would be x. Move the y on this side, so we will have x plus 2y equal to 9, right? Now notice that now the equation 1 and equation 2 now has the same numbers in front of both x and y. The numbers before x and y determines the slope, okay? Because the slope relationship is calculated this way. Now what that means is that then you have these two lines then have the same slope. If they have the same slope, that means they're parallel, like that graph that we saw, okay? They have the same slope like that. Or like this, doesn't matter. Okay, the point is they have the same slope. And therefore, they will never intersect. Things that have the same slope are parallel, and there is no way that this is going to intersect. And that's why this is called an inconsistent system. An inconsistent system has no solution. Now, you might say, what if I just, I don't know, plug x of this thing in here and see what happens. You can totally do that, and that is what the book did. Now, if you do that, you can see that, so the book then plugged x into y there, okay? And then when they did, then you do some math, and you end up with 9 equal to 13. Well, 9 cannot possibly be equal to 13. The reason you come up with that answer is because your system is nonsense. So in other words, there is no solution. Because any solution, if you have a solution, then that solution will prove the 9 equals to 13, which is not acceptable in the math that we know. So therefore, no solution exists. So next, let's look at the next example. Next, let's look at example 9. Now, example 9 says we have two lines. One is x plus 3y is 2. And the next one is 3x plus 9y equal to 6. Now, if you look at the two equations carefully, you quickly notice that the two equations are the same equation. You just multiply 3, the first equation, you multiply 3, but it becomes the second equation. If they're the same equation, then there is no point, there's nothing to solve, because every single point on the line is shared by both lines, because both lines are actually on top of each other. So that's that case where there is a dependent system, you get nowhere, okay? So that's example 9. So next, let's look at example 10, where we have a word problem. Example 10, we have the cost and then the revenue, or something like that. We don't care. The point is that what they want to know, where's the break-even point? That is, when do these two things equal to each other? Okay, and yeah, we'll call this. So when are these two things the same? Well, that's not much worth mentioning. So if they're the same, that means this equal to that. So I'll write that down, which is so then 1.55 x equals to 0.85 x plus 35,000. So then to solve for x, then we have so x equal to move this over there, okay, and then so we have 35,000 left, divided by this minus this, right? 1.55 minus 0.85, and that's about it. Let's crank this out on the calculator. We have Yeah, let's see. On, my calculator turned off. There. Okay, so we have, I'll punch in 35,000 and then divided by 1.55 minus 0.85. That should do it. Okay, let's see if we come up with anything sensible. That's 50,000. Let's see, is that the answer? Yep, that is the answer. Okay, and the next question the book wants to know is, what is the profit formula? Well, the profit formula is R of x, and that's the one we looked at, minus C of x. So R of x is this thing. Let's see if I stand over here. Yeah, as you can maybe see it. Yeah, well, anyway, R of x is this thing. There. Okay, C of x is that thing. You subtract it, which equal to this, and that is your profit function. That's really not much worth mentioning, right? It just revenue minus cost is profit. That is, yeah, not really worth doing, in my opinion. But anyway, let's go to the next example. So let's look at problem example 11, which is more interesting. Now, the cost of the ticket of some event is $25 for kids and $50 for adults. All right. So then on a certain day, the total number of people attended is 2,000. So let's call C for kids, okay, and then A for adults. Then the total of C plus A is 2,000. So we have 2,000 kids or adults that attended the event. And the total income that day was 70,000. So the kids are paying $25. So $25 times the number of kids, that's the total amount that from kids. And then twice that much plus $50 from adults, that will give us a total of $70,000. $70,000. Another zero. Okay, and so that is the system of equation that we need to solve. Now, first we are going to divide this thing by 25 at least, so that the numbers are not so big. So that becomes C plus 2A, okay, and that equals to, that divided by 25 is, I don't know, let's use the calculator so that I don't have to think too hard. So let's do 70,000 divided by 25, 70 divided by 25 is, okay, that is 2,800. Okay, so then, so we have two equations right here, right? And then we are going to use equation 1. We'll take C out of equation 1. So C equal, being that that's very easy to do, C equals to 2,000 minus A, 2,000 minus A, and then plug it into the second equation, well, right here. Okay, this is equation 1, and this is equation 2. We'll plug it into, that is not good. Too close. Okay, this is equation 2. Let's plug this thing into equation 2. So then C is this thing, plug it in here. We have then 2,000 minus A, and then plus 2A, that equal to 2,800. If that is the case, then we have minus A plus A, so we have A left. And then 2,800 minus 2,000, that's 800. So there are 800 adults, okay? And then C is 2,000 minus that amount, so then C equal to 1,200 kids. So that should be the answer. Now let's see if I got it right. And let's see if next page. A is 800 and C is 1,200. See, that is that. And with that, we have come to the end of the section. So for homework, which is on page 696, please do the problems I assigned. I'm not going to read them out here because I have a total of about 23 problems, which is a lot. Normally, I don't assign that many. But this section of systems of equations is extremely important. And so it's very important for you to do enough homework problems to be thoroughly good at this, as good as possible. And also the word problems are more interesting, okay? Like kids and adults going to circus and that sort of thing, which I find more exciting to do. So the So please give yourself extra time in this section and get all the homework done. So it will take a while, but please do spend the time, because systems of equations is going to be used to all the way through calculus and beyond. So it's extremely important that you're good at it. Okay, so please do the homework as I post in the video description. And when you're done, come back and then I want to talk about some of them. So problem 17, we have the problem says 3x plus 5y equals to 9. And then 30x plus 50y equals to something else. Now, what you need to pay attention to is this number right here. See, it goes from 3 to 30, 5 to 50. It's proportional. That is, we can divide this equation by, say, 10, okay? Then we will get the same numbers here. Except the last number is different. But these are parallel. That means these two lines are, but they equal to different numbers, which means they are parallel lines, okay? And then because they have the same slope. The same slope are numbers that has corresponding numbers that's the same, because that's how you calculate the m. And so as a result, if these numbers are the same or proportionally the same, then these lines are parallel, and that means there's no solution to problem 17. Now let me check the answer. So I checked the answer, and that is what the book says. No solution for problem 17. So next, let's look at problem 19. We have half of x plus 1/3 of y equals to 16. And then 1/6 of x plus 1/4 of y equals to 9. All right. So for this problem, let's make everything into, I don't know, common denominator or something. That I might not have enough space. Yeah, I think I better erase the board. So the first thing we're going to do is get rid of the fractions. To do that, we're going to multiply by 6. Okay, that should do it. To multiply by 6 of equation 1, so I'll write down equation 1, I'm multiplying by 6. Okay, that would be, maybe I shouldn't write down multiply like that, because then I confuse with x times 6. That gives us, that may be 3x. And then 2y plus 2y, that is equal to multiply by 6, right? So 16 times 6, that's 96. And okay, and so that's the first equation. And the second equation, we're going to turn it into 12. So we're going to multiply by 12, right? Yeah. Multiply by 12. So the first equation becomes first item becomes 2x. And then the second item is 12 divided by 4 is 3. So still plus 3y. And then 12 times 9 is 108. So far so good. All right. So then we got to this point. So the next point we're going to do is, let's see, let me find my stuff. Okay, now we're going to call this equation right here 3, okay? And then this one, we'll call it 4, just to keep track of things better. So then equation 3, and we're going to multiply it by, see, there's 3x and 2x, so we'll turn it into 6x, but we're going to make one of them minus and one of them plus. That way they will cancel out when we add them up later. So let's take equation 3, and we'll multiply it by minus 2, okay? Equation 3 times minus 2, that will be minus 6x, and then minus 4y, and that equals to times minus 2, that is negative 1819192. So that number is getting bigger and bigger. And in the meantime, we'll take equation 4, that is this thing, and then we'll multiply it by positive 3. So then that will give us also 6x. That's what we're shooting for. So they're the same except with a different sign. And then this thing has to times 3. That's plus 9y. And that equal to times 3. Okay, that's 324. All right, so now we finally get to add these things together. So then this becomes 0, okay? This becomes positive 5y, and that equals to these two numbers, 324 minus 192. That's I don't know, what is that? That should be a 2 at the end, and then 3, and then 1, or something like that, I hope. Okay, so that doesn't look like a very good answer. Let me check the answer to see if I'm right, so that I can catch my mistake. Well, my answer is right. This is just not a very pretty question, okay? So, I mean, the question is not too bad, but the answer is just not that pretty. So then the y end up being 132 divided by 5. Ugh. I wouldn't design a question like that. But, well, anyway, so then x, we'll plug x into one of these things. How about this one? So then 2x, writing this stuff down, okay, we'll have from equation 4 again, we'll rewrite equation 4 and becomes 2x equals to 108 minus 3y, and which means x equal to 108 minus 3y divided by 2. And we're going to do that on the calculator, because that way we don't wear out our brain doing this type of thing. So let me grab the calculator after I find it. It's right here. Okay, and we're going to do, what are we doing? This thing right here, 108 minus 3y over 2 with y equal to that thing. All right, so we will do, let me turn on the calculator, and then 108, I will type in 108 minus 3 times what? Put y in parentheses, okay? So let's, to be sure that everything is proper. So let's put, so minus 3 times 132 divided by 5, close parentheses, okay? And so that's, yeah, that's not good enough. We need parentheses here too. So I need the parentheses in the beginning, like this. And then divide by 2. So I need to go back and add another parentheses to the beginning. Okay, in my case, I can just go to the end. The end is the beginning. Add another parentheses. Yeah. Yeah, see? Now I have a parentheses in the beginning. And then go to the beginning is the end. So divide by 5, minus 5. And then that is just for the division. I need another parentheses. And then now I can divide. Okay, now I can divide by 2 equals. All right, that equals to 72 over 6. 5? No, 72 over 5. And that is correct, okay, according to the back of the book. So that is problem 19. So here's problem 29, which says minus 0.2x plus 0.4y equal to 0.6, and x minus 2y equals to negative 3. All right, now you notice that this goes from 0.2 to 0.4. It's a doubling situation, but with different signs. This goes from 2, and it's also a doubling situation with different signs. You know what that means? It means that the number here are proportional. That is, this thing, if you multiply it by the right number, will become this, okay? And the right number would be, I would say, minus 5. That is, if you take equation 1, okay, times 5, 1 times 5, that will give you times actually minus 5. If you take equation 1, this thing, and times minus 5, it will give you equation 2, except for this part will be different, maybe. No, I think even this part is the same, right? The whole thing is just the same, which means that these two lines are identical. And yeah, because 0.2 times 5 is 1, right? Minus becomes positive 1. Is there a negative sign here? Yes, there is. Okay, so then, and then 0.4 times minus 2 is minus 2. 0.6 times minus 2, minus 5 is, times minus 5, okay? We're multiplying by minus 5. So this also equals to that. So then it's the same line, okay? You can always multiply a number on the equation without changing it. It's the same equation. So the two are the same line, and therefore there is what is this called? I don't even remember what they call it. It's not inconsistent. It was the other one. Whatever. The point is, we can't, there's nothing to talk about because you only have one line. There's not enough information to give you a specific solution because every point solves the 2 equation, being that 2 is the same equation. So, okay, let me see what the book says. The book says, what? What is that? Now, give me a second. Let me see if I'm reading something wrong. Okay, now I look at the answer at the back of the book, and it gives the parametric representation, which we haven't covered yet. So please ignore the answer. Okay, the point is there's nothing to say here, or maybe they did. Let me check to see if the book did give the parametric representation. I'm just not paying attention. I guess the book did give the parametric equation as the solution, which is okay. So please go back to let's look at example 9 again on page 693. So in example 9 on page 693, the line was this thing, and the 2 lines was just one, just like this situation, the 2 lines on top of each other. So the book gave the answer this way, without explaining why or nothing. So I will do the same. Okay, so if your 2 lines are the same, the answer we'll write it like this. We'll write it as x is just x, whereas y is that thing. So you write it this way: 3x plus 2/3. Yeah, so that is just another way of saying this. So it's not much of an answer. And similarly, for problem 29, then we'll solve for y. I will do it over. So then y equals to from here we can have y equals, move the y over here. Okay, it becomes x plus 3, right? So the positive over here, and so the y is over here times a positive 2, which we divided here. So the answer to problem 29, if you want to write it the way the book wants it, is x comma x plus 3 over 2, because that's what y is if you solve for it, and which is just the same way of saying this. Okay, this is called the parametric representation, which you haven't learned yet, and but the book wants to do that, so I will explain it just so that you know what the book is talking about. So that, in other words, y is just well, you stuff the equation of y in the y solution, and x is just x. Yeah. Anyway, so but we're not focusing on parametric representation right now, so it's of no real significance. So let's move on to the next problem. So next, let's do problem 39. All right, so which is 2.2x plus 1.3y equals a negative 0.1, 4.2x plus 4.2y equal to 2.1. All right, so that is that should be right. So so let's do this. Now, how are we going to do that? And we're not going to multiply anything for least common denominator, nothing. Okay, we're going to do it the brute force way that I mentioned earlier. That is, we're going to plug one of these things out, doesn't matter which one, and then stuff it into the other one, and hope that we don't make a mistake and everything will come out. So from equation 1, let's call this equation 1, and this will be equation 2. So then from equation 1, we get x. Okay, let's figure out what x is. X then equal to minus 0.1 minus 1.3y, right? Put that over there, divided by 2.2, and that should be x. So knowing that, then we are going to stuff x in here, okay? And I am running out of space, so I will save space by doing this. This is x, okay? Remember that. This is x. We'll multiply it by 4.2, and stuffed it in here, plus 4.2y, 2y, and that's going to be equal to 2.1. So this is an equation with just one variable, and we should be able to come up with what y is as long as I don't mess up, right? And so so that would be equal to, let's write down what it is, okay? And let's see. So we have this times this times this minus this times that. Okay, so y values are, let's see, we'll put the y value over on this side. All right, so let's write down the y value. So y times a bunch of stuff, okay? There's 4.2, that's there. What's the y value here? It's 4.2 times times negative 4.2 times negative 1.3 minus 1.3, and then divided by 2.2. 2.2. All right, this is multiply. Okay, this is the dot for multiplying. All right, the big dot there. Okay, so that's everything y, right? 4.2 times negative 1.3 and divided by 2.2. Yeah, that looks, and then plus the 4.2. That's everything in front of y. And on the other side, we have 2.1. Okay, and then minus whatever is here. That's a number. So minus 4.2 times negative 0.1 divided by 2.2 is okay. So let's write that down. That is 4.2 times we'll write it in parentheses, times 0.1 times 0.1 divided by 2.2. 2.2. Okay, so which means if we type in all this in the calculator and divide it by all this, that should give us y if we don't make a mistake in that process. Okay, so that's what I'm going to do right now. So please do that yourself also. Okay, and I'm showing you how to use the calculators to avoid certain problems that students tend to have when they have when they use calculators, so that you can watch me do it and see whatever mistakes that I might make, and then learn how to do this yourself. So then, because we're doing dividing and there's a subtraction there in the numerator, right? This is being divided by that, so we need parentheses. Otherwise, the calculator will give you something it will make you unhappy. So anyway, we have, so start with parentheses, 2.1 minus parentheses 4.2 times 0.1 close parentheses. Yeah, okay. And that parentheses probably isn't necessary, but we put it in, divide by 2.2. Okay, so that is close parentheses. That should be the first parentheses, right? Let's check this a little bit. So we have 2.1 minus 4.2 times 0.1, and then divided by 2.2 close parentheses. What am I doing? Where am I? There. Okay. Actually, we'll push equal now to see if it's spit at us. If it spits at us, that means it's not happy. Okay, so far so good. We didn't type in anything wrong, probably. So then, I'll go back and continue. Continue what? Divided by this, everything that's on the left. Okay, start right here. Divided by, first thing, parentheses. And then we need another parentheses because there's two of them there, right? And then we have, what am I doing? Let's see, 4.2 minus 1.3, okay, divided by 2.2, okay, then plus 4.2, then close parentheses. Yeah, that looks okay. So let's push equal and see if it gives us anything. So that is the value of, what is this? This is y. Ugh. Let's see what the answer says. This is problem 39. No, I'm wrong. And the reason is because I wrote this poorly. Okay, I thought it was 4. When I was typing, I thought it was 4.2 minus 1.3. It's not. It's 4.2 times 1.3. That's why I have a giant dot there, which is a mistake because I just ignored my giant dot. What I should have done is just write down parentheses. See, that's 4.2 times negative 1.3 instead of just minus. So I got back to that point, and 4.2, let's see, we'll add times parentheses 1.3. Okay, so we have 4.2 times 1.3. and then divided by 2.2, and then plus 4.2. So let's see if that looks better. That gives us 10 over 9. That's still wrong though. Let me check again. Okay, I found my mistake. Guess what? See this? The negative sign here? Okay, when I subtracted it over there, forgot the negative sign again. I'm telling you, the negative signs are basically the death of me. So let's put in a negative sign here. See, this is times negative 0.1. So I will fix the calculator, okay, where I need the 4.2 times minus 0.1, minus please, minus 0.1. Okay, now let's see the answer. It says now it equals to 4/3. And I think, yep, that is correct. Okay, so what do we get? So y is equal to 4/3. I'll write it up here. Or maybe down here. Okay, so y equals to 4/3. Y equals to 4/3. And then x is this thing. Okay, remember that's where we got x. This whole thing is x. So and in the parentheses. Yeah, so let me maybe use a different marker. And I'll draw this whole thing like this. So this whole thing equals to x. This is just x. And then, and so we'll plug y into that x equation and figure out what x has to be, okay? And so y is 4/3, so let's do this some more. And so let's clear this thing, and we get, so x equal to, first, don't forget the parentheses, because there's a minus sign here. When you do division with a minus sign, don't forget the parentheses, otherwise it won't do it right. So, okay, we have parentheses, okay, negative 0.1 minus 1.3 times y is 4/3. We don't need parentheses there because of multiplication. Divided by 2.2 equals, I think I messed up again. Okay, yep. Let me check where I messed up this time. Oh, I typed in something wrong. Look at that. What is that? And let's fix that. Minus 0.1. Okay, 0. Minus, what is all that? Anyway. Okay, minus 0.1. Okay, and then minus 0.3. Minus, where's my 0.1? Sorry. 0.1, minus 0.1, and then minus 0.3 times, etc. Okay, try again. Now I'm even worse. Okay, let's see, 0.1. No, I think I typed in wrong. It's not minus 0.1. I have to type in negative, okay? Negative 0.1, and then this is minus. Minus, yeah. See, my calculator makes a difference between negative sign and minus sign. Some calculators don't. Okay, so now let's see if it works. Okay, negative 5/6, and that is correct. Yay! It's always exciting when I finally get the right answer. Okay, so that is the fun part of math. Part of the fun is, oh wow, check this, I got it right. Goodness. Okay, so that equals to minus 5/6. And that is fine. So and that is the answer. Now this looks like kind of a tough problem, but now that I'm done with it, I was looking at it when I was looking for mistakes, and I noticed something that I didn't really pay attention to when we started the problem. That is, look at this. This is 4.2. The point got disappeared from here, but there is a point here. Okay. I'll write it back. So it's a 4.2x, 4.2y, and 2.1. You know what that means. That means this equation is actually, this is 2, 2, and 1. We can rewrite this equation as just equal to this. That is, the equation 2 is just 2x plus 2y equal to 1. And that will make, does that help? I don't know, then we don't have to type in 4.2 so much. We can just type in 2 instead of 4.2 and 1 instead of 2.1. So we'll save a little bit of typing, and yeah, other than that, it's the same deal, okay? And so that is how you do problem 39. So I will finish this section in the next video.